In this lab, we were using copper chloride, which is an ionic compound. The solution that you were given contained 1 molar copper chloride that had the solid already dissolved in water. However, I want to take a minute and review that as a solid, copper chloride forms this network type structure where we have a positive ion, a negative ion, positive ion, negative ion, and that's what we call our lattice structure. In this drawing, I've kind of color-coded it where the negative circles represent a single chloride ion and the positive gold circles represent a copper ion. When we put the solid in water, what immediately starts to happen is we say that it dissolves. The reason for that is the water molecules or particles, it doesn't matter which language we use at this point, have what's called a partial positive charge on one end and a partial negative charge on the other end. And so we see those water molecules that come in and they line up where they've got these charges oriented, and it'll start to, it's a negative, break down. We have another positive here, here's a negative, positive, and it'll pull apart all of these copper and chloride ions that had previously been locked together. The end result, once the copper chloride is completely dissolved, is we have all of those ions kind of evenly distributed throughout the water, and water molecules that have arranged themselves surrounding all of those different ions. So if we zoom in on one of them for a moment, here what we see is here's our negative chloride ion. It's got water molecules that have surrounded it. Each water molecule is still neutral, it's just the molecule has oriented itself with the positive side of the molecule attracted to the negative chloride ion. If we look at a copper ion, we see something similar in that we have the negative side of the water molecule that has oriented itself towards the positive copper ion. This represents the setup that we were using, where we had the 2 pieces of graphite that were connected to the battery inserted to our solution. We had the cathode, which was our negative end, the anode that was positive. Through the solution, what we can't see happening is that we have a flow of electrons that are moving from one end of the graphite to the other end, and they're going through the solution, through the graphite, into the wire, and it's complete throughout the battery. The reason the cathode side is negative is because that is the side that the electrons are leaving. Remember, the electrons we represent with this E minus because they have a negative charge, and the anode has our positive charge because that's where the electrons are flowing. That's the attractive side. Let's first analyze what was happening on the cathode side. What we saw was that there was a collection of copper forming, but it was solid copper. So around that graphite, we saw that copper. The reason for that, when the copper was still an ion, it had a positive charge, and it had some number of electrons. And because it had a positive charge, that meant that there was more protons than electrons, or it was essentially missing an electron, therefore it was not a neutral atom. Because it was attracted to this negative cathode, it had the ability to kind of pick up one of these electrons, therefore balancing it and making it neutral. When it was neutral, the water was no longer attracted to it, pulling it apart, which is why we were able to see it come together and form the solid copper at that end of the cathode. Once that happened enough times, that's where we got to see the solid copper that was kind of growing in amount, especially on day 2 after the reaction had occurred overnight. On the anode side, what we saw was gas bubbles forming. Those gas bubbles were actually chlorine gas. The reason for that, the chlorine had a negative charge, and therefore it was attracted to the positive side of the electrode or the anode. Because of that, strong positive charge, the chlorine, which had a negative charge, meaning it had an abundance of electron, actually lost one of its electrons that entered kind of that flow of electrons moving throughout our circuit. And when two chlorines that were near each other each lost an electron, they came together to form chlorine gas, which is what we saw exiting as a bubble. So just to recap for a minute, we had positive copper ions that were attracted to the negative cathode, or the negative side of the battery. They were gaining electrons from this flow of electrons that was the electrical current. When they gained an electron, they became neutral. As a neutral atom, water no longer was ripping them apart or dissolving them, and so they came together to form our solid copper that we saw as a precipitate. On the other side, we had negative chloride ions that were attracted to the positive end of the battery, the anode. They had an electron, because they had an abundance, they had an electron that left the ion. When it did that, the two now neutral chlorine atoms were able to come together and form a chlorine molecule that was a gas, and we saw that exiting the solution as bubbles.